Another cool feature of the ArFi and HEBO combination that is part of the ArFi Premium package is that you will be able to do sweep measurements to figure out what is the resonance frequency of the entire system. So to do that, we can say, okay, what will be the force that we are going to pressure with? Let's say in this case it will be around 3 Newton. So what we will do is we'll have here 3 Newton set up exactly. Then what we will do is we will go to max force. So that means that now the probe will again move down, see that it touches, move a little bit up, and then pressure down again. And as you can see, it's slowly approaching the max force of 3 Newton. Now it reached 3 Newton max force. And what we want to do now is we want to go to time-based haptic measurements here in the corner. So now we can do a longer measurement and we can do it without the probe actually moving up and down. So what we do is we quickly change it to maximum time. So here we'll set up a 20-second measurement. And what we will then do is we will do a sweep. We will do a sweep from the HEBO in this case. And to do that, we have already set it up. We have 20 steps from the frequencies of 100 to 900 Hertz. So we are way above what we would actually have. So we are into the almost that we can hear the haptics. So this is not the intention, but this is just a demonstration. So now what we will do is we will get ready to play the sweep. And at the same time, we will start our haptic measurement here. So we click the interface and now it will start the measurement. And as soon as it starts, I will click sweep. And now the device is sweeping. You can maybe even hear it. And now it's finished sweeping, so we can go over and we can stop the measurement. It will save the data. And once the data is saved, we can view it. For longer measurements, it will take a little bit longer to save. But once it's saved, we can go to the graph window and we can actually open it up. And what you now see is a sweep of frequencies. And here you can actually see that in the very beginning of the frequencies that we played, we actually had a higher signal than what we had over the later span of signals. That means with the same amount of energy, we could have higher acceleration amplitudes. So if we go back to the HEBO, we can see that the first was 100 Hertz, the second signal was 142, the third one was 184, and then we had 226. So if we go over here, then this one would have been 100, 142, and then we have 184. This will then be our resonance frequency because we see that that has the highest amplitude across the frequency span that we did. We can now close in the range so that we can have an even more detailed sweep across our surface to get closer to our result. Let's try that. So what we do now is we go even closer. So we go from, let's say, 300 to 280 to 100 Hertz, still 20 steps. So we will go back to our panel. We will go ready here. We see it has gone down a little bit. Something has moved during our test setup. So we will slowly, maybe here, increase our force. We see that we are at 3.3 Newton. That's okay. And now what we will do is we will do the sweep again. So we do the time-based haptic. We start the measurement, and then when it's started, we do sweep. It's done sweeping, so we can go over, we can stop the measurement. It will save the data. Once it's saved, we will go to the graph. And here, now we again see for the very first frequencies we had much less, and then here in the end we had more, and then it will slowly increase. So if we look at this according to the other one, then we have 1, 2, 3, 4, 5, 6, 7, 8. But we won't do that, that's ridiculous. We have a program for that.
Here we have the ArFi analyzer program. I've loaded in the sweep from the accelerometer measurement that we did. And what you see here is we can take the selection area tool, move it across what we believe is the resonance frequency. We'll see an identified frequency of 171 Hertz. For this here, we can see also the FFT and the power spectral density for the accelerometer measurement. And at the same time, we can go in and we could move it to the next step, and we could see that the identified frequency is now 180, and so on and so on and so on.